Okay, so as we know, if spherical mirrors. So first of all, what is a mirror? You guys tell me. Even what is a spherical mirror? Hmm. Go ahead. Don't. It's not. Pen tab is not. Wait. I think today is going to be the most irritated day for your session and with your session. First of all, this pen is not working. Beta, just give me a minute. I need to maybe change the room or I need to talk with the IT member. Okay, just a minute or two. Hello. Am I audible? I'll try once if it is going to work. Mhm. Sorry, beta, it's not working, so I have to change this. Okay. No, it's not working at all. Mhm. Just wait for a 5 minutes. Hello, 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 hello. Am I audible? Am I visible also? Hello. Yeah, this is perfectly fine. Okay. Am I audible, visible clearly to each and everyone here? Yes. Sorry for the inconvenience. Okay, so starting from the beginning now. First of all, good evening, everyone. This is going to be our most important, largest chapter in class 12 physics. That is ray optics and optical instrument. In this particular class today, we are going to talk about spherical mirrors, mirror formula, and the derivation of mirror formula, which is going to be in your syllabus for the class 12. There are magnification also. So there is two types of magnification. One type is given in this. Okay. Another type I'm going to tell you guys. So just wait for a while. Meanwhile, yes, just a minute. When you already wait a lot, let's the formula is there. Okay. So this is all about your real. I mean, we already learn about it on mirror in so many great detail, or you can say in class 10th itself. So that is a spherical mirror. We start with this spherical mirror. Okay, a spherical mirror or a mirror that is a part of a sphere is a mirror that has the shape of a piece that is cut out of a spherical surface or material. There exist two types of spherical mirrors, which are convex and concave. Very simple, very easy, very basic. If you forget, how you remember, simple, there is a sphere. Okay, if you cut that particular sphere in any particular sense, suppose you cut in this way. Okay, just a minute. If you cut in this way or in this way, the main important thing is where you're going to apply a silver paint or a color. If you apply the outwards part here, so the first kind of a mirror is behave as a concave. Simply concave. Concave stands for a cave kind of a shape, means curved inside. A kind of a mirror in which is made up of a spherical, or you can say a sphere, simple, and you pointed out or you painted out the silver color on outwards part. Okay, so that particular type of mirror is known as concave mirror. Concave mirror. Clear, everyone? And if we painted out on this inside, or the spheric, the reflection is going to be take place from the outwards part. So this particular kind of a mirror is known as convex mirror. Is this clear, everyone? This is known as convex mirror. So basically, with the help of even spoon, we can understand. First of all, open your cameras, everyone. With the help of spoon, even we can understand the difference between this. There is a spoon kind of a structure. If in this way, I'm going to show you. So this outwards part of my hand behave like a convex mirror, or you can say the opposite part of a spoon is behave like a convex mirror. And the front part, with the help of that particular part, we eat any particular kind of soupy or liquid stuff, that particular part behave as a concave mirror. Is this clear, everyone? Majorly, why it is known as spherical mirror? Because it is made up of a sphere in this way. Okay, so that is the main thing. Now, as I recall, as we already done this part also, the speed of a light in a vacuum is the highest speed attainable in nature. That is all in this sense, that is C equals to 2.99724558. So approximately we are going to do this 10 to the power 8. 8 and 8 again going to be written down here. So that is 10 to the power 8. Okay. Control Y. And then just draw this. So 10 to the power 8 meter per second. Clear? In the previous lecture we done this. Light have a dual nature. Light can behave as a particle also. In the class 10th we learn, and light can behave as a EM wave, or electric field oscillation and magnetic field oscillation. Spherical mirror formula. So this is spherical mirror formula. The focal length of a mirror is equal to the half of the radius of a mirror. What is? There is so unsymmetric thing in this PPT, and I have seen. Just a minute, bit. Directly spherical mirror formula, and why it is not situated in this? Why should I need to arrange everything? Okay, done. Yeah. So spherical mirror formula, the focal length of a mirror is equal to the half of the radius of a curvature. Okay, we already know this thing. The radius f equals to, the focal length is r by 2, where f is focal length of a spherical mirror, and r is the radius of a curvature of a spherical mirror. So if you guys are confused what it is, so as we know, each particular kind of a spherical mirror is made up of a sphere of radius r. Okay, this is the radius r. So if I make a particular kind of a, just a minute, suppose this is your one, this is my one of the mirror. Okay, I can do this. Yes, now it is perfect. And this is my convex mirror in that particular sense. We can assume this. And as we already know from the previous class, there is a principal axis. What is the principal axis? A perpendicular axis which passes from the point, or you can say optical point, midpoint. So if any particular ray is going to be parallel, okay, if any particular ray is going to be parallel to this, so after the reflection, it is going to be on the focus. So in that particular sense, after the focus. So a point on which all the parallel rays are converged after the reflection, that particular point is known as focal length. Is this clear, everyone? I think that is just clear in your head, and if it is not, so revise that concept. And please, beta, open your cameras, everyone. Again and again, I don't want to scold you, and I'm saying scold. So believe me, I can do that. Okay, so this is your focus. So there is a relation between f equals to r by 2, because we already learned this thing. The f equals to, there is a, this particular derivation we done in the class 10th. Okay, r equals to, or you can say f, radius of curvature equals to 2OF. 2OF means 2f. And if you don't remember how we can do that, so there is a case, I can tell you how we can do that. With the help of mirror formula, we can do this. If I put any particular, what is the mirror formula? First of all, you guys tell me. Because we can do in two ways. First, with the help of geometry. Second, with the help of mirror formula. So with the mirror formula, I think you remember. With the help of geometry, maybe or maybe you not remember. But with the help of mirror formula, you need to. There are 6 cases. You remember or not? First of all, tell me this. Remember, na? Everyone, I'm asking this. There are 6 cases for concave mirror, 2 cases for convex mirror. If you put any particular object at the center of curvature, which is you can say radius of curvature also. Okay, C is here, center of curvature, or this is also known as the distance from the optical center. P is radius of curvature. So if you put any particular object here, so you get the same size object, same size real one. Clear? So here U equals to V equals to R, obviously negative R, and we know this mirror formula. Using the mirror formula, what is the mirror formula? Please, anyone tell me what is the mirror formula? You remember or not? First of all, anyone? because we're going to derive in this class. The derivation we are going to do with the help of geometry, if I'm not wrong. Sign convention, we are going to do that. Focal length of mirror formula, and this, and the cases, obviously. Image formation cases, we are already going to revise. Properties and derivation of mirror formula, we are going to. That is purely theoretical, but it is necessary. Anyone, please, what is the mirror formula? Forgot mirror. Oh, seriously? 1 by f equals to 1 by v plus 1 by u. Exactly. Sai and Dhanmeshwar. Is this? I'm laughing on you. Sorry, but I have to be tough. How can you forget this? So many things I need to rearrange in your lecture today. Sometimes I think I am doing a treasure hunt in your lectures. I need to change the cabin. I need to settle down this camera thing. I need to do this, that, and so many things all together. Yeah. So mirror formula is 1 by f equals to 1 by v plus 1 by u. Okay. And I don't know why you forget, but it's okay. It happens. That is very easy. How? Okay, I can write here. 1 by f focal length equals to 1 by v plus 1 by u. And there is a similar length formula, but in length formula, there is going to be negative. So if v equals to u equals to r, obviously negative, and for concave, for concave mirror, f is negative. Why it is negative? If you forget that also, so it's okay. There is a sign convention. What is a sign convention? Sign convention states that we are going to revise everything. Don't worry. That's why I'm asking. With the help of sign convention, everything kept on the left hand side is going to be taken as a negative. So as you seen here, this is my, as you seen here, that is my concave mirror, and everything in the concave mirror is going to be kept on the left hand side. Focal length, okay, focal length, object distance u, and even an image distance v. Is this clear? This is your focal length. This one is your object distance, and this one is the image distance v. So everything is left hand side. Everything is putting on the left hand side according to the sign convention, that is positive, that is negative, positive, negative, and negative. Clear? So that is why we take as a negative thing. So simply then 1 by f equals to minus of 1 by r, minus of 1 by r, which is going to give me minus of 2 by r. Okay, so minus cancel each other. So from here directly we can say that 1 by f equals to 2 by r, and reversing this thing, f equals to r by 2. So if you guys don't understand or just forget according to the geometry, so at least in this way you need to understand this thing. Okay, so that is how we can derive this even. Is this clear? How f equals to r by 2, and f is the focal length of a mirror, r is the radius of a curvature of a spherical mirror. Clear, everyone? Good. Done. Okay. So magnification of a spherical mirror. What is the magnification? Magnification of a spherical mirror is nothing. Magnification is basically the ratio of the height of the object to the height of the image. I is height of the object, O is height of the image. Okay, so in definition wise, you need to define in this way. It is defined as the ratio of the height of ratio of the height of the image to the height of object, to the height of object. Okay, as you can read it out, I is the height of the image formed, O is the height of the object formed, V is the image distance, U is the object distance. So that is basic. In general, they don't ask this, neither they give you. Is it clear? What it is in general from the previous page, if I can draw for you, most previous. Well, no. Magnification. Just wait for a minute. Magnification, this. Okay. Hmm. Hmm. This magnification is general in known as lateral magnification. Lateral means linear. There is one type of magnification more we have, that is known as aerial magnification. Okay, so this is your important thing. Lateral magnification. Lateral means magnification. Lateral means in one direction. What is the meaning of this? Okay, just a minute. Wait a bit. You guys are thinking like, sir, sir, say wait a minute at least 20 times till now in this class, because see, the thing is, most of the thing is given, but not in a proper manner. I need to rethink. I need to recheck again and again. Okay. Means the things are given. I'm not feeling happy for you guys. I can teach you the same line, but that is not the part. See, there are two types of magnification. First of all, lateral magnification and aerial magnification. What is the difference between a lateral magnification? Suppose there is a pinpoint object. Pinpoint object is very slim object. Okay. So what is the height of an object? And the ratio of the height of the image to the height of object. For example, if you are standing in front of a very big plane mirror or any particular kind of mirror, so you seems like a pinpoint object, straight line, single line, right? So that kind of magnification is known as lateral magnification. But in that particular sense, what is another aerial magnification? If you put an object in front of that, so area is going to be changed. So that particular magnification is known as aerial magnification. And from class 12th, the magnification formula just work for aerial magnification. And the formula I already given to you guys. This is more important as compared to the previous one. Other formulas are important one because that particular thing you already done in the class 10. Clear? So they don't ask question on this simple magnification, and even you don't know the name of this. That is lateral magnification. So is this clear? That is known as lateral magnification. And what is the meaning of a lateral magnification? Simple as that, as I already explained you. If this is the height of an object and that is the height of an image of mine, okay. So in now, as you can see clearly, that is I and that is O, and they are pinpoint. Pinpoint means simply stand. But instead of that, I can draw this one also. Instead of that, I can draw just instead of that, I can draw this. Okay, and then the image of this is going to be, if I make a large in this way, or if I want to make a small, so that is going to be in a reverse case. Okay, but maximum number of time for from the concave mirror we get real and enlarged image. Clear? Is this clear, everyone? And there is one important thing you going to observe also. Whenever there is a object is kept very far away, so the image is formed at the focus that is very diminished, very small. The more we you can say move our object towards the closer, move our object towards the mirror, the more large image we get, inverted one. But after this particular focal, in between focal point, focus or optical center P, if I make an object, if I put an object, so I get real and virtual erect image. That is the special case. If you forget so, okay, we're going to revise just a minute. So what is an aerial image? Now you can see aerial image is nothing but the multiplication of the lateral image, because that is one lateral that is one lateral magnification, that is another lateral magnification. Clear? And the proper formula of aerial magnification, here it is. Wait, I need to check it out. Because you guys never ever get a question on this. Uh, Images, because according to the images you're going, yeah, that is the perfect image. Just a minute. Is this visible? Clear? So as you can see that there is that is I am talking all about, that is your aerial magnification, and the formula of aerial magnification is nothing but very simple. The formula of your aerial magnification is, okay, let me write it down, then I'll explain again. Aerial magnification. That is very important, because on this particular I given you guys 3-4 questions. I know this, so that is why specifically deliberately I want to teach you. So aerial magnification is nothing but the product of linear magnification in x-axis or y-axis. As simple as that. Okay. If you know the linear magnification, how much it is going to magnify this or how much it is going to magnify this. So obviously area is what? Length into breadth. So in a same sense, if you know the magnification of a length, which is x-axis, or you can say if you know the magnification of a breadth, which is y-axis, so automatically multiplying both of that magnification, you get the aerial magnification. Is this clear, everyone? Should I need to repeat it again? If you don't understand, so please ask me here, because believe me, only on this formula, okay, only on this formula, and what the formula I'm going to give you guys, on that formula you guys going to get the this kind of question. Okay, so angle subtended by the image at a pole, or you can say angular magnification is also there, but angular magnification is only just so that is your aerial magnification is area of image to the area of object, that is MA cross B. Proper, I am going to give you this. So what is the formula then? Aerial magnification Magnification is nothing but MA is M cross A into M cross B. What is this? M is lateral magnification here. A cross B means the ratio of the height of the image in x-axis or height of the image in the y-axis simply. Okay, and then that is MA is M square. What is M over there? M is nothing I by O or V by U. Wait a minute, बेटा. हेलो. नहीं नहीं, मैं तो क्लास, वो पहले का आया होगा, मैं तो क्लास में. Hello, hello. Sorry, I don't mute myself, but it's okay. I don't talk something else like you don't need to listen. Okay, so as you know, that is M square, or M is basically I upon O, V by U. So aerial magnification formula is one, that is the important one also. M A V square upon U square or I upon O square. Is this clear, everyone? And that is important one also, beta. Is this clear? And that is how you can get it. I by O, V by U, again with the help of mirror formula. So we know mirror formula equals to 1 by F equals to 1 by V. V and U and to make a very different. Okay, 1 by V equals to 1 by U. So if we know the focus and U only. So as we know, that is what it is, V by U. So 1 upon V equals to 1 upon F minus 1 upon U. Okay, and you can do this 1 by, I mean, if you want to find the V, so that is going to be Fu into F minus U. And then we can take out common U also. Okay, so just by that you can say deriving this 1 by V or V, simply you can put it in this way. So if we know only and only focal length and object distance, so we can use this. And if we know only and only focal length and image distance, so we can use this formula. And that is very, very important. Okay, so revising all the main important things about magnification. First of all, what is magnification is? Magnification is just the ratio of the height of the object to the height of the image, or it can be also defined as the ratio of the image distance to the object distance. Okay, then there is a lateral magnification. The simple magnification we learn about I upon O or equals to minus V by U. There is going to be negative sign also, minus of V by U. Then if magnification is positive, so the image is going to be erect. If the magnification is negative, image is going to be inverted. That is the sign convention. If you get the negative image, negative magnification means the in this sense, because if image distance is going to be negative, okay, so that is going to be inverted one. And if it is going to be positive in this sense, so it is going to be erect one or parallel to the perpendicular y-axis, positive y-axis. Mode of magnification is large, image is going to be greater than that. If magnification is lesser than, so small image is going to be there. Clear, everyone? Now, if you guys know only and only focal length and object distance, so that is the formula. Focal length and image distance, so that is the formula. So that is important. More importantly, we have a aerial magnification. Aerial magnification is nothing but the magnification occur and happen in the x-axis or y-axis simultaneously. So that is MA, which is M square. M is I by O or negative of V by U. Is this clear, everyone? Beta, just write it down, type it if it's clear, so I can go ahead. Because after that, I'm going to teach you page by page, line by line, what is clearly mentioned and written on this particular PPT. Clear, everyone? Good. Now this is the real life connect. As you guys see over here, this is a kind of a what kind of mirror it look like. It is a concave mirror. It is a convex mirror. It is also a convex mirror. Okay, so it is a concave one. Concave mirror, what it is like a dish antenna or any particular antenna which is going to capture most of the light, or a solar panel also. It is simply convex mirror. Maximum number of times you going to see that in large shopping center, mirror mall, or you can say malls, or in metro stations, and that is your side mirror view, or you can say side view mirror. That is also there. Application and everything is written over there, so don't worry about it. We are going to talk about it also. So that is your basic terminologies of spherical mirror. Uh, that is, F is focal point, C is center of curvature, F is focal length, P is pole. So what is pole in general? Pole is the midpoint of a or optical center. What I am talking about, pole. This is your pole, midpoint. This is pole. Okay, and this one also. And what is principal axis? A line passes through a perpendicular line passes through the midpoint of a mirror or focal length or focus point or center of curvature. That particular line is known as principal axis. Is this clear, everyone? So this is your reflecting surface. This is your concave mirror. This is your reflecting surface. That is your convex mirror. That is very easy. I don't need to even teach this. We already done this thing in the previous classes. Clear na? What is focal length? What is this? What is that? Or should I need to explain it? Okay, C, center of curvature. The distance is in between, that is R, radius. That is the center of what? That is the center from which sphere we make these kind of mirrors. Simple. Okay, this is structure of spherical mirror. Here F is focal point. I mean, this is the same thing, R, radius of curvature. So from this particular example, or from this particular slide, you can see that this is convex one, this is concave one, this is aperture. Aperture means the part which is going to give us the reflection is known as aperture. This is pole, or you can say optical center. The length between pole and F, focal point, or you can say focus, is focal length. The distance between pole and radius, center of curvature, is known as R. Principal axis, what it is? A line perpendicular, or you can say a perpendicular line passing through the pole, the midpoint, focus, and center of curvature is known as principal axis. Nothing more than that. Okay. So now types of spherical mirror. In general, there are two types of spherical mirror. Concave mirror and convex mirror. We already know about it. Concave mirror. A concave mirror. What is a concave mirror? A concave mirror, or you can say a spherical mirror, which of the reflecting surface is curved inward, which means that it faces towards the center of the sphere, is known to be a concave mirror. The back of the mirror is always shaded to that reflection can take place only from the inward bulged surface. Okay, use of concave mirror. Converging mirrors are most widely used in shaving because they have reflective and curved surface. A concave mirror is used in the ophthalmoscope. What is ophthalmoscope? Is whenever we going to a dentist. So dentist is known as ophthalmoscope, or dentist, or you can say that which is going to do your eye specialist doctor. Okay, ophthalmology means doctor which is going to do the treatment of your eyes. These mirrors are also widely used in making astronomical telescope. In an astronomical telescope, a converging mirror of a diameter of about 5 meters or more is used as the objective. Converging mirrors are used in headlights of automobile and in motor vehicles, torching lights, railway engines, etc., and as reflector. See, this one is very important, and this is based on single application. Whenever an object is situated in between the pole or a focus. So whenever there is an object for this particular kind of mirror. This, suppose you put an object here in between the focus and pole. So what happened? We are going to see the image is going to give the image is very enlarged, erect, and wide open. So that is the use of this. Large converging mirrors are used to focus the sunlight to produce heat and solar panel. This is your solar furnace also, kind of this one. Okay. As you can see, large concave mirror going to capture more and more light, and when they capture more and more light, so they convert more and more solar energy into the light energy. So that is the use. Convex mirror. Convex mirror, a simple one, as we already know this thing. A spherical mirror having its reflecting surface curved outward is known as to be a convex mirror. The back of the mirror is shaded so that the reflection only takes place from the outward bulge part. The surface of the spoon, which is bulged outward, can be assumed to be a convex mirror. It can also be as a known as a diverging mirror, as the light after reflecting through its surface diverges to many directions but appears to meet at some point where the virtual erect image of a diminished size forms. Okay. Use of concave mirror. Use of concave mirror means the most important uses are: concave mirror are used inside buildings so that people can see all around the building at once. The convex mirror is used in vehicles. Convex mirror are commonly used as a rear view mirrors in case of the automobiles, the vehicles, because they can diverge light beams and make virtual images, and you can see the large area of the behind scene. These mirrors are mostly used for constructing magnifying glasses in industries. To construct a magnifying glasses, two convex mirrors are placed back to back. Okay. Magnifying glasses means a particular glass which is going to give you magnify, means with high resolution. Another use of convex mirror is diverging mirrors are also used for security purpose. In many places, they are placed near ATMs to let the bank customer check whether the same or not. Convex mirrors are also widely used in various other places, for example, street light reflectors, because they can spread out over the bigger areas. Sign convention, as we already discussed. What is the sign convention? Everything on the right hand side is going to be taken as a positive. That is positive. That is positive. That is negative. That is positive. That is negative, and that is negative also. And how we can say that? Obviously, we are going to do. We are going to assume the pole. Why this pen is not? That is much enough. So we are going to assume that particular pole. Okay, this is my pole, na? This particular pole P is as the origin. So if pole is, we take pole as the origin from which we are going to observe the height of the image, height of the object, not height of the image. Height is going to be observed from this principal axis. The object distance, the image distance, and the focal length we are going to observe from this. The height of the image, the height of the object we are going to observe from this. This is my principal axis. Okay. And this is your pole taken as the origin. So everything on the right hand side taken as a positive, everything on the left hand side taken as a negative. Height of the object taken as a positive because it is going to be upward. Height of the image, that is real inverted image. That is real inverted image. Real inverted. What is the meaning of inverted? Anyone tell me? What is the meaning of inverted? Anyone know here? Upside down image. Exactly. Inverted means upside down. As you can see that there is an object and that is image. So object is in the upward direction, in this direction, and your image is in the downward direction. So that is your inverted or upside down. So that is height towards the negative side. So that is why real inverted image V is going to be -1, where the virtual erect image, if I make a virtual erect image, suppose this is your virtual erect image in this way. So this one is going to be, this one is going to be virtual. This one is going to be virtual erect image. Okay, this is my virtual erect image, and this is obviously if it is a virtual erect image. So then sign convention according to the sign convention, V is going to be positive. Clear, beta? V is going to be positive. So that is your sign convention. Clear, everyone? So every particular thing, downward side is taken as a negative. Every particular thing, left hand side is taken as a negative with the help of this sign convention. Sign convention for spherical mirrors. According to the sign convention, as we already know, all distances are measured or taken from the pole of the spherical mirror. Objects are close, considered to be placed on the left hand side of the spherical mirror U. So as you can see, U in any particular case is taken to be negative. Okay, F for concave is going to be negative, and okay, I can give here downward. Wait for a minute. This is your concave one. Just a minute. Yeah. With this, you're going to understand clear. Let me draw this. I mean, let me paste it, and then I'll let you know. Oh, wow. Good. Okay, just a minute. Yeah. So as you can see, this is the sign convention. I mean, sign convention we already understood. We already talk about. So this is the pole. This is the pole, and this is my principal axis. Perfect. And here is my pole. Just a minute, just a second. Okay. So as you can see from this right hand side diagram, object distance. Object is placed on the left hand side always. If I want to make any particular image, even with this particular thing, even with this particular convex mirror, even, so I draw image here, and already I drawn image here. I mean object here as well. So object's distance U is going to be negative. Is going to be negative for both the mirrors. Okay, so U is negative always. You can write it down in this way. Is this clear, everyone? Now, focal length for convex mirror. As you can see, focal length for convex mirror is going to be positive. Why so? Because focal length and the focus point is right hand side of the mirror, where the focal length for a concave mirror is going to be negative. So if you get any particular focal length in negative sense, or you can say if there is a question and there is written down focal length is -25 centimeter, so automatically you get an idea in your head that is a concave mirror. Is this clear, everyone? Okay, and from where we get this information? From the sign convention. Meanwhile, if image distance is positive, only in two cases is going to be positive. For convex mirror, it is always going to be positive because image is diminished and virtual and erect. Here we found in this way. But for convex mirror, for concave mirror, we get only in one cases image which is virtual and large when I put my object in between focal length, or you can say in between focus and pole. Okay, so V is going to be positive. There is a catch always, or you can say for convex mirror, always, okay, and V is going to be positive. For concave mirror in one case only. Hello, yes, who's this? Yashodi. In one case only. Okay, so what is the catch? In one case only, the image is going to be positive. So directly you can say that if for a concave mirror you get an erect or virtual image or a positive image, so the V is positive gives you one thing more clearly, the image is virtual and erect. What is the meaning of virtual? Please anyone tell me. What is the meaning of virtual? Arre beta, you already done this thing in class 10 and you don't know this. Seriously, what is the meaning of virtual? Anyone please? I need to tell you this even. Are you serious about it? Huh? What is the meaning of virtual? Nearly? Seriously? Virtual is which is not in real. Virtual. When the rays of light are not meeting in real, we get a virtual image. You forget everything. Either you do the rectification in class 10, or either you don't learn anything in great detail in class 10. There are two options always. Okay, I mean there are two ways, or you can say part of each particular or maximum particular thing in life. Either the head is going to become, or either the tail. If you throw a skin, if you flip a coin, so either heads or either tail, right? So there is two things in science or physics as well. Either you don't learn at that moment when there is in class 10 in great detail, whosoever the teacher taught you, what is left hand side, what is, I mean, you can see the sign convention, mirror formula, magnification, and this virtual erect everything, or either you do the rectification. So it's okay whatever you do. If you don't know, so please let me know. The erect image that is formed. What is erect then? Sir, no, but don't know how to explain. Due to diverging rays, not exactly visible. But a virtual is visible. Every particular thing is visible, na? No, I start laughing on you. See, okay, 2, 3 things you need to confirm. Again, there are the cases we're going to learn when the rays of light are not going to meet actually. So that particular thing is known as a virtual image. Online classes, yeah, that is the case. But in online classes, you need to learn more, na, because there is going to be more proficiency. And but you guys are in 10th, na, so it's okay. Because in 10th class, no one is going to be serious. So I can understand that. But it's okay. If you don't know, so at least now you learn. See, what is virtual image? A kind of an image in which the ray of light is not going to intersect. We are going to talk about ray of light also. Yeah, this is ray of light. Okay. And real image is going to be when the ray of light are going to be intersect after the reflection. What is a ray of light? An imaginary line passing through, you can say an imaginary line which is originated from the object is known as incident ray, and after the reflection it is known as reflected ray. That is, you know already or not? Incident ray, reflected ray, principal axis. Is this thing you guys know, or I need to start from that? I think I start from the very uh, not basic thing. I think you know these things, so that's why I don't consider. But okay, I tell to the other teachers or tutors here, like who are going to teach the NEET student and other batches of yours. Okay, so that is sign convention. And okay, I'm going to start again with the virtual and real. Just take a break. I take the break now. Take a 5 to 10 minutes break, and then we are going to talk again. Then we're going to start. I need break now, and I think you guys also. Hello, 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 hello. I'm audible. Am I visible? Everyone, are you there? Hello, hello, hello. Yes, okay. So where I was, real and inverted image, kind of image in which the rays, or you can say reflected rays, are meet in actual. In general, they are known as real and inverted. Inverted means upside down. Virtual and erect image, that a kind of an image in which we don't, in which the reflected rays are not meeting in actual, that is known as a virtual or erect image. Erect means directly same as to the object. You guys are going to see in a minute in this. What is the meaning? Deep core meaning. A spherical mirror, as we know, when a parallel beam of light incident on a concave mirror and a convex mirror, we assume that rays are paraxial. Paraxial means they are incident on a point close to the pole P of the mirror and make small angles with the principal axis. As you can see, every particular principal, every particular parallel incident ray has a single point. Okay, single point, single point. That particular single point is in actual is known as a focus, and the distance between focus, or you can say point of focus, and pole is known as focal length. Nothing more than that. As now this is dotted ray is a virtual ray, or you can say it is not considering, it is not coming at this. Why so? Because this is a diverging mirror and it is a converging mirror. Concave mirror also known as converging mirror. Why so? Because it's going to converge each particular ray. It is going to converge each particular ray. Converging mirror. It is going to converging mirror. Okay. It is going to converge each particular ray, incident ray, and that is known as diverging mirror. Why so diverging? Because it is going to diverge all particular coming rays on that. Okay. So obviously, if it is going to diverge in opposite sense, in opposite side, in this way, so they are not going to ever meet. But we have a focus, we have a, you can say, focal length, we have a center of curvature also. So we say that in this particular scenario, what is happening? They trying to the same color I picked. Sorry. They seems to converge, or they seems to meet at a single point, and these dotted lines basically are virtual reflected rays. First of all, because they are not occurring, they are not happening in real. But we have a focus also, we have a center of curvature also. So we say that we find there is a point behind the mirror. Okay, there is a point behind the mirror where all the reflected rays, or you can say where all the virtual reflected rays, virtual reflected, okay, virtual reflected rays are going to meet. Is this clear? Is this clear? And that is why that is also known as virtual. Virtual means not in real. Simple as that. In concave mirror, the reflected rays converge at a point F on the principal axis, where in convex mirror, the reflected rays appear to diverge from a point F. As you can see, it is appear to diverge from this particular point of focus. And that is why it is known as diverging mirror. And that is why it is known as converging mirror. Is this clear, everyone? Please turn on your cameras, everyone. Is this clear, beta, everyone? Clear na? So, the image formed by these virtual reflected rays are known as virtual image, and the image formed by these real reflected rays are known as real image. Nothing more than that. Clear? I hope and I believe this is clear. That is very easy. Then focal length of a spherical mirror, I already explained you guys what it is. So the point F is called the principal focus of a mirror. If the parallel paraxial beam of a light were incident making some angle with the principal axis, the reflected rays converge or appear to diverge from a point P in a plane F normal to the principal axis. This is called focal plane of the mirror. Okay, so this is your focal plane. This particular plane in general is a focal plane, or the length from this particular point to the mirror is known as focal length. This is your pole and that is your focus. Okay, and a plane considering that particular focus, object distance, or sorry, object height, image height is known as focal plane. And that is your image formation by concave mirror. So at infinity, as you can see, that is very important. At infinity means if you are going to see the image of a sun. Why we take a sun as an infinity? Because on the earth, from the earth, the sun is at very far away. So we can say we find that is at infinity. So whenever the object is situated at infinity, light rays are going to come in parallel, and parallel light rays are converge at a point of focus. So the image you're going to get at the principal phase is real inverted, extremely small in size. As we know, sun is very large as compared to the earth or any particular mirror on the earth, but still we get the size, still we get the image of this particular sun very small. So that is why we say that very small, diminished. Extremely smaller in size is also known as diminished image. D-I-M-I-N-I-S-H-E-D. Clear? Now, if we move our object towards the mirror, as I can put behind the sea, beyond the center of curvature a little bit. So in between center of curvature and focus, I get my image. Between principal focus and center of curvature, diminished, real and inverted. These all cases are already done in class 10. So I can skip a little bit early. Skip a little bit means I can give you this way and then switch to the main thing. If, as I already let you know this particular case, if any particular object is situated at C, so at the C means at particular center of curvature we get the image, same size, same height, everything. Clear? So if an object is situated, pointed, put it at the center of curvature, so at the center of curvature we get the position of image, same size as the object, real and inverted. Now, if we move our object more near towards the mirror, now we put our object in between C and F, as you can see that, so we get enlarged image. Okay, beyond center of curvature, if we put an object between focus and center of curvature, so we get the image beyond center of curvature, magnified and real and inverted. Magnified means real, enlarged. If we put a particular object on this particular focus, so this is, we are going to get at infinity and highly magnified. Highly magnified means very large. Now if we put our object in between the focus and pole of a mirror, so as you can see we get the enlarged image, virtual and erect, behind the mirror. So that is the very, very important case, this one. Other cases are also important, but this one is very important. This one is also very important. And this one is most important. Is this clear, everyone? You guys know this thing. You guys already learned this thing in class 10th even. Now properties of image formed by concave mirror. We are going to discuss this quickly. So what it is, point size image, highly diminished in size, a real and inverted image. The parallel lines which come from the very distant object at infinity after striking the reflecting surface of the concave mirror get reflected back and meet at a point, or we can say in this case converge at a point. This point is known as principal focus of a concave mirror. Okay, now this is image formed by convex mirror. So there is only two simple cases. You put an object anywhere. If you put an object at infinity, very, very far away, in convex, so image it is going to get at principal focus, or you can say behind the mirror at principal focus, highly diminished, virtual erect. Highly diminished, virtual erect means the image is this one, very, very little, very, very small in size, but erect and virtual. If you put an object in between the infinity or a pole, so you get the image in between the focus and pole. Again, diminished, virtual and indirect. Means very small, or you can say erect and virtual. Is this clear, everyone? There are only two cases over there. In the same sense, the properties of image formed by convex mirror, the image formed is highly diminished in size, virtual and erect. The parallel rays which comes from the very distant object at the infinity after striking the reflecting surface of the convex mirror get reflected back and appear to meet at a point, or we can say in this case the diverge from the surface of appear to meet at a point. This point is known as a principal focus of a convex mirror. Now, derivation of the mirror formula. So first of all, what a mirror formula is? Mirror formula is 1 by f equals to 1 by v plus 1 by u. We are going to find the derivation of this. So the following consideration are taken in order to get the mirror formula. The object and image distance are being measured from the pole of the mirror. We know this thing. According to the sign convention, the negative sign indicates that all the distance which are measured in the direction opposite to that incident line indicates all the distance which are measured in the direction of incident ray. The distance below the axis is the distance below the y-axis is taken to be negative, whereas the distance above the axis is taken as the positive. Means we're going to see in the next page. So suppose there is an object. Okay, there is a, obviously if it is going to revert back, this is an object is situated in between F and B. So one ray going to be parallel, any particular ray which is going to be parallel, that is coming on this particular point of focus, or if any particular ray is passing through C, so it is going to come back at the particular C. So this is your object. Okay, so obviously it is going to be U, and if it is the image, so obviously it is going to be V. And as we can see, image is below the particular horizontal axis, so it is real inverted. Real inverted, okay, and it is erect. Real and erect. So from the figure above means the previous figure. Okay, one thing I tell you in the beginning of this derivation, this is going to be a little bit boring or more theoretical, but it is necessary for the subjective for your class 12 also. So from the figure above, the object AB is placed at a distance U from P, which is known as the pole of the mirror. From the diagram given, we can also say that image A1B1 is formed at V from the mirror. And now from the diagram, it is clear that according to the law of verticality, vertical opposite angles, the opposite angles are equal to each other. So it can be written as angle ACB equals to A1C1B1. For that, we need to wait, I can draw it from this because the diagram is necessary for you guys. Just a minute, beta. So this is your diagram. Okay, on this particular diagram, what they already discussed about it. Clear this one? So as what is written over in this line, in these lines, this is angle ACB. This angle is going to, this is not going to visual. This angle is equal to this angle. Obviously vertical opposite angle. So angle A1B1, A1CB1 is equal to the ACB. Vertical opposite. Is this clear? Vertical opposite angle. And rest of the things I already described on the previous page. We are going to prove with this 1 by f equals to 1 by v plus 1 by u with the help of geometry. This is clear, everyone? With the help of vertical opposite sign, and we learn this thing in class 10th even. This is vertical opposite angle. So ABC, or you can say angle ABC, where AB is the object, is equal to the angle A1 ABC ACB A1CB1, and that is ACB, not ABC. ACB. Maybe clear? Why so? Vertical opposite angle. Why so? Vertical opposite angle. Simple. Rest the other thing I already described in the previous page. Vertical opposite angle. Okay, vertical opposite angle. Okay, now moving ahead, this is vertical opposite angle. Now, similarly, the triangle FED. Now, what is FED? I need FE. Okay, FED. FPD only. Sorry, I start speaking. FPD. That is FPD. And FA1B1 are equivalent derivation. Oh my goodness, so many things. Even I am going to get bored to explain this. Wait. Okay. See one thing. Yeah. Again, so many times I need to copy paste this form. Okay, wait a minute. I first of all copy paste this thing and then teach you in a one go. Wait a minute. Wait a minute. I don't know why you guys don't get on each page. Yeah, done now. Because each page required a diagram. Good. Mm-hmm. Okay, so this is your diagram. So similarly for the triangle FED, FED is said for this FPD. Yeah, instead of E, it is P. Okay, this is FPD and FA1B1. Now, if you take this particular angle FA1B1 and FPD, this triangle or this big triangle. So PD. Okay, this PD is going to be equal EF. Now, what is EF? What particular thing they describe in this EF? EF. Where is E in this triangle? Wait a minute. See, this is EF. Okay. I can do one thing. Instead of making P, I can make this P. That is going to be more clear. We can take the pole instead of P. Pole is E here. Is this clear now? Because that is more easy to make. Because if I am going to repeat once and once again and again, so that is going to be. So now triangle FED, this is E, FED and triangle FB1A. So similarly, as you can see that these are quite similar, both of the triangles. So ED, this ED upon A1B1, ED upon A1B1, because this is the perpendicular kind of thing. So ED upon A1B1 equals, there is a property of similar triangle. The ratio of the corresponding sides are equal. You know this thing or not? First of all, you tell me. You know this thing, na? In class 10th, we done this thing, properties, or you can say if triangle ABC is similar to triangle PQR. So, according to the similarity of this, ratio of corresponding side, ratio of the corresponding side, the ratio of corresponding sides of the similar triangle is equal to the similar triangle is equal. Is this clear? So using this particular rule, we are going to find this. So as you can see, ED upon A1B1, this is correct then. ED upon A1B1 because this is corresponding side, perpendicular kind of thing, and EF is this horizontal line equals to the FB1, this FB1. Also, since ED is equal to AB, as we can see that ED is equal to AB, parallel to AB, so we can take that instead of ED, AB. AB upon A1B1 equals to EF upon FB1. Clear it out. Is this clear, everyone, till now? Is this clear, everyone, beta? Please let me know. Okay, so combining equation 1 and 2. And what is the equation 1? Because as we see in equation, yeah, this is my equation 1 and this is my equation 2. What is equation 1? This is equation 1. This is equation 2 and there is no equation 1. Or is there any equation 1 also? So many things is going on here. This is your equation 1. Similarly, triangle ABC. Okay, where is triangle ABC? Yeah, this is your triangle ABC. As you can see now, triangle ABC, this one triangle and A1B1C is also right angle triangle, and they also similar to each other. Now since two angles of triangles ACB and A1C1B are equal, therefore third angle is also equal. What is the meaning? See, two angles are perpendicular. Okay, these two angles are equal, so the third angle is going to be equal. Angle BAC equals to angle BAC. This angle is needed to be equal. Then if the two angles are equal, so ratio of the corresponding side of two angles is going to be equal. A1 AB, I mean this AB upon A1 B1 equals to the BC. This BC upon B1 C1. This is your equation 1, and equation 2 is in this page. So combining equation 1 or equation 2, because in both the equation AB and A1 B1 is going to be equal. So AB upon A1 B1 is going to be here F this EF upon FB1. FB1. This is my equation 1. This is my equation 2. Combining both the equation, what I get? BC upon B1C equals to EF upon FB1. This equation. Okay. Now combining these both of the equation, BC upon B1C, combining equation 1 and 2, BC upon B1, B1C equals to what it is? EF upon FB1. Clear? This is my equation number 3. Now it is clear, everyone? Is this clear with everyone? Okay. So derivation. So this is till now we learn this. Moving ahead, consider point D. Consider point D very close to P. Say EF, or you can say this. This is point again E. I need to make this common. Okay. And this is point E. Now consider this particular point D is very close to P. So EF, or you can say this particular point P, E. So EF equals to PF. Therefore B1 C1, this BC divided by B1 C1 equals to PF upon FB1. From the diagram, BC equals to, I mean this BC, this is BC. How you can find BC? Simply, hello, yes beta. From the above diagram, BC is going to be PC. I mean this again, A, they can write P instead of E, minus PB, which is R minus F. Okay, so BC is PC minus PB, which is R minus F. As you can say, if I make this P, okay, as usual, so PC is R, and then PB is object distance. Is this clear? And in the same way, B1C, this B1C, this distance, this particular distance B1C is again PB1 minus PC, PB1 minus PC. So it is going to be image distance, because PB1 is image distance minus PC is R. Okay, so this is important. So now BC upon B1C equals to PF equals to FB1. Simple. Okay. And from the above diagram, BC and this, I mean FB1 and this, we already just find it down this. values. What is FB1 and C and so and so. Moving ahead, substituting the value of PC, which is minus R, PB equals to U, PB1 equals to minus V, and PF equals to F. Why minus and everything? Because it is a, you can say, concave mirror. In concave mirror, everything we can take. If we say that is a concave mirror, so there is going to be on the left hand side and object is going to be the right hand side. So above equation, what is the above equation? Above equation is this BC upon B1C equals to PF upon FB1 is going to in this way. And solving this equation, equation number 4, you can say. So solving this equation number 4, and what is equation number 4? BC upon B1C equals to PF upon FB1. This is my equation number 4. And putting the value of BC from the previous, if I want to, BC equals to R minus U. Okay, and here I need to take minus R. And then B1C I can take. B1C I make here V minus R, so it is going to be minus V of minus R. Minus V of minus R, and then PF is going to be obviously negative of F, right? It is written over here. And then FB1 is, what is FB1? FB1, wait, from here you can understand. Yeah, FB1 is, I already make this side, FB1 is distance is again PB1 minus PF. Okay. If you want to find the FB1, what is FB1? This FB1 is PB1 minus PF. Here PB1 is of minus of V and PF equals to minus of R. So this is my FB1. Putting this, I mean every particular value, I already wrote it down here. B1C, BC, and PF we already know, minus of F, and then FB1. So the above equation converted into this, and when we solve this equation, so just taking out the negative sign, so it is going to be U minus R and it is going to be R minus V. Clear? Because U going to be positive, here R is going to be positive, here F is going to be positive. So we can convert this equation into this. U minus R equals to R minus V minus of F upon F minus U. Then taking negative common, and it is going to be V minus F again. So solving it, we get this. And solving further as R equals to 2F. Okay. After solving this, UV equals to minus UF equals to 2FV plus FV. So solving it further, we get, I mean divided with the equation UV. If you are going to divide this particular whole equation, UV equals to UF plus VF. If we divide whole equation with the UVF. Okay, this is one term, not completely UVF. So if I am dividing this equation number 5 by UVF, UVF. So now we get this 1 by V. Okay, 1 upon UV upon UVF is 1 by F. UF upon UVF is 1 by V, or VF upon UVF is 1 by U. So we get this. Okay, and from this fifth equation comes from, as we know, solving this till now, cross multiplying U minus R equals to V minus F, R minus V equals to F. So we get this. Okay, then UV, this UV minus UF minus RV minus RF. So RF cancel each other because both are the same. Minus of VF converted into the positive VF. So UV minus UF minus RV plus VF. Clear? Equals to 0. As we know, R equals to 2F, radius of curvature of the focal length. Therefore, we are going to put R equals to 2F in the previous equation. And what is the previous equation? This UV minus UF minus RV minus VF. Means we, instead of R, we are going to put everything into the form of UV or F. When we do that, we get this equation, UV equals to UF plus VF, and this equation number 5 divided with the UVF all. Okay, dividing with UVF, we get this mirror, and which is required mirror formula. I know this is a little bit tricky thing, but beta you need to do. Why so? Because sometimes, not sometimes, maximum number of time in theory exam you're going to get it. Is this clear, everyone? Okay, re-revising everything once again, because after that is easy. This, till now we know this is vertical opposite angle, so this particular angle is this particular angle, and if this particular angle is equal, so we say that using the, and after this page needs to become first of all, and angle triangle ABC and triangle A1B1C is right angle triangle, and if angle C is equal and angle B is right angle triangle, so the third angle is going to be equal, obviously, then angle BAC equals to angle B1A1C. So with this corresponding, I mean the ratio of the two sides of a same angle is going to be equal. So that is why AB upon A1B1 equals to BC upon B1C1. That is my first equation. Going back to the page, using similarity property of triangle FED, or you can say FPD and FA1B1. So we get this. Now using equation 1 and 2, combining both, we get BC upon B1C1, or EF, or you can say PF upon FB1. Okay. Then we find the values of this B1 and C1. Nothing more. We substitute the value. PC equals to minus R, PB equals to U, B1 equals to minus V, PF equals to minus R. We get every particular value with the help of diagram. Then just mathematics, I mean rearranging the formula and cross multiply each other. Here we do the cross multiplication. After doing the cross multiplication, we cancel out the same term. After getting the term, we just put R equals to 2F to get every particular value into UVF. And when we get the main important equation number 5 into the terminology of UVF, we divide the whole equation with the UVF, and we get the important mirror formula, which is 1 by V plus 1 by U plus 1 by F. Clear? Moving ahead, if an object is placed at a distance U from the mirror and its image is formed at a distance V from the pole, then we have this relation 1 by V equals to 1 by U plus 1 by F. In this formula to calculate, this is formula to calculate the unknown quantities are substituted in a proper sign. The sign convention is very, very necessary. You don't need to change the sign even if you are doing the reverse thing. Okay. If an object, if a thin object of linear size O were situated vertically on the axis of a mirror at a distance U from the pole, and its image of size I is formed at a distance V, magnification transfers, we can say transverse magnification, lateral magnification is defined in this way. I by V equals to minus V by U. Here negative magnification implies that the image is vertical, inverted with respect to object, while positive magnification image that means the image is erect with respect to the object. We already done this thing. Okay. For a positive erect image, negative inverted image. Greater than 1, magnification greater than 1, automatically V is greater than U, or I is greater than O, so large image. And magnification, mode of magnification is smaller than 1, lesser than 1, so it is a negative case, or you can say small image. Other formula of magnification, again M equals to F minus U, M equals to FB minus U. We already done this thing. Power of a mirror is defined. Power of a mirror is also be done. Power of a mirror is going to be asked. You don't have power only and only for lenses. So power equals to 1 by F in nanometer. Negative sign is important there. Okay, the focal length of a spherical mirror of a radius r is given by this. In sign convention, f or r is negative for concave or converging mirror and positive for convex mirror. I already explained this. Newton's law formula for f square equals to x1 x2, where x1 is the position of the object with respect to the focus, x2 is the position of the image with respect to the focus. So if in general in any particular question you get this, so there is a important thing. You don't need to do the derivation. Clear? Moving ahead, this is your question. Do that. Now the theory part we already done in this. Just this CAS do CAS assisted practice and this self practice is needed to be done. So complete it. Meanwhile, I can I need to assign this homework for you. I don't think so. I assign class assessment is there. Okay, because of this changing room and so and so. I just a minute. Meanwhile, you can do that question. That is very easy. I'm not going to tell you. And I don't think so. I need to tell you. Focal length of a concave mirror is given. So automatically when the focal length of a concave mirror or a convex mirror is given, so you need to put a sign. Clear? Where an object is placed so that image is 2 times and is inverted. So you one hint I can give it to you. A. And real inverted means V is positive. Okay, real inverted na. Inverted is when an object is replaced so that its image is 2 times. Image is 2 times. Use this and tell me the answer. I need to check beta. Is this A or something else? Hmm. What they ask? Yeah, M equals to F minus U. So using this particular, I mean you need to use obviously that. A is the correct answer. For real image, magnification is 2 using M equals to F minus U equals to minus 2. You have everything and you need to find U. Okay. Is this clear everyone? How you need to do that? Everyone beta. Just give me 1 second. Is this clear to each and everyone or not? Just type it if it is not. Clear na? Good. Do this. Same kind. Image you need to tell me. Here you need to use mirror formula and then you can find M equals 2 minus V by U equals to I by U. Do this also. Okay, so what it is given in this, an object of size 7 centimeter, size object means O, place at a centimeter, U is always negative, 27 centimeter, in front of a concave mirror. Concave mirror F is concave is going to be minus of 18. At what distance from the mirror should a screen be placed? Obviously V, to get a sharp focus image obtained. So find the size and nature of the image. So automatically use 1 by V equals to 1 by F. Find V. With the help of V, you need to find whereas M equals to I by O equals to minus of V by U. Okay. In this sense, we can find I. I need to check beta, is this 14 or something else? Yes. A. If everyone, I mean, two students get A, so obviously the answer A is correct. The rest is incorrect. So using mirror formula, we can get, okay, V equals to minus 54 centimeter. So U is minus 20, H2 upon H1, which is I upon O, and that is H1, which is I is given, O is given object size or object height. So H2 is 14 centimeter. Nothing more than that you need to do. And in this way, we can finish this introduction of reflection of light by spherical mirror, sign convention of mirror, focal length of spherical mirror, and the mirror form.